All right, guys, welcome. Hope everybody's doing well. Hope you guys are healthy. Hope you guys are happy. This is our first video in our home learning series, so I just want to jump right into this. I'm going to try to make these videos as short as I can, and I know today my setup isn't very good, but I have a bigger whiteboard coming, so the videos are going to get better starting next week. All right. Okay, so let's jump right into this. Series circuits. This is what we're talking about today. Okay. What is a circuit? All right, a circuit is the way that we get electricity to flow, okay? Whenever we draw them, we draw circuit diagrams that look like this, okay? In a circuit diagram, we're only gonna have two things we need to worry about. We have batteries and resistors. Batteries are two lines, a small line and a big line. The negative end of the battery is the small line. The positive end of the battery is the big line. If you've ever seen a battery before, you know that they have a positive end and a negative end. And then we have these lightning bolt looking things. These are our resistors. In this case, we have 1, 2, 3 resistors. Each resistor is 3 ohms and our battery is 9 volts, okay? We know that this is a series circuit because a series circuit is one single loop, all right? Okay, let's take this a step back and talk about what a circuit is, okay? So in order for electricity to flow, it has to be able to go from the positive end to the negative end of the battery, all right? So if you connect a conductor, a wire, a piece of metal from the positive end to the negative end of a battery, all of the electrons that are in that battery, all of that voltage will flow through that wire, okay, and go through the circuit. If you attach resistors into that circuit, the electrons, the electricity will flow through them. Now, in this case, these resistors are 99 times out of 100 in physics class, they're going to be light bulbs. But there could be anything. Anything that uses electricity is a resistor, all right? In order for the electricity to flow, it has to be one complete circuit, one complete circle. If you cut off any point, if you go whoosh, okay, you just cut that circuit and now the electricity no longer flows because those electrons no longer have a positive end to run to, right? So remember, voltage is how many electrons are flowing, okay? The more voltage, the more the electrons flow, right? So here, what I just did was I just cut that wire. I just put that wire back together. Now we have a completed circuit. Okay, draw a printer. All right. So, again, I know that this is a series circuit because if I put my marker here and I go from the positive end through each resistor to the negative end, I never have to pick my marker up. It's one single loop. It never splits. Okay. All right, so that's the first thing we need to do. Identify it as a series circuit. Number 2 is we need to look at the current, the voltage, and the resistance and what they do in this circuit. Okay, so here's the 3 things that you got to know. Number 1, in a series circuit, the current is the same everywhere. Okay. Number 2, the voltage drops over every resistor. So what that means is I have 3 resistors and 9 volts. Okay. Each one of these resistors is going to get a piece of those 9 volts, all right? Which means, in this case, they're all equal, so each resistor gets 3 of those volts. So when the electrons come out of the battery, okay, they go through the first resistor. This resistor eats 3 volts. The next resistor eats 3 volts. The third resistor eats 3 volts, okay? It comes back to the battery, no volts. But don't worry, the battery juices it back up, 9 more volts, and they go back through all of the resistors, lighting up the light bulbs, okay? The current's the same everywhere. The voltage drops over every resistor. The resistance, okay, just adds up, okay? So if I wanted to find my total resistance, I would add up R1 plus R2 plus R3. In this case, 3 plus 3 plus 3 is, very good, 9. So we got 9 ohms of resistance in the circuit, okay? So that's everything that you need to know about series circuits. Now, what we're going to do is we are going to look at an example, okay? And again, I know I'm going a little fast. All of this information is in the PowerPoint. It's all right there. I know you can't see it in the video, but it's on the PowerPoint, okay? Here's our batteries and our resistors. So let's look at our first example here. I gotta erase this and I'll draw it again. All right, so I'm gonna draw this circuit real quick. I have one 9-volt battery. So I'm gonna draw that like this, 9 volts. And I have 3 resistors. 1, 2, and 3. The first resistor is 100 ohms. The second resistor is 300 ohms. And the third resistor is 50 ohms, okay? Here's my circuit. I got a battery, it's got a positive end and a negative end, okay? And I have 3 resistors, 3 squiggly lines, okay? And I labeled each of their resistance. In order to solve any circuit problem, we are going to use something called a VIR chart. So whenever you see a circuit, okay, the first thing you're going to do is you're going to write down the letters V, I, and R. Voltage, current, resistance, all right? And this chart is going to be your salvation. This chart makes every single circuit problem into a puzzle, all right? And it makes them 100 times easier to solve. So here's your chart. You write down VIR and you count how many resistors you have. In this case, we have 1, 2, 3 resistors. So we got R1, R2, and R3. And at the bottom, we have a total, okay? So how do we use this chart? You can think of it kind of like a Sudoku puzzle. So we're just gonna fill in everything we know. So the first thing we know is that we have 9 volts coming straight out of the battery. So I put in my 9V right here. Okay, I know my total, not very well drawn. My total voltage is 9 volts. So that goes right there. The next thing I know is I know the resistance of each one of these resistors. So I know R1 is 100, R2 is 300, R3 is 50. Okay, R1, R2, R3. All right, now what do we do? Well, we have to use those 3 rules that I just showed you about the resistance, the voltage, and the current. Hopefully you're sitting there yelling and you're like, well, you told us to find the total resistance. All you gotta do is just add them up. So that's what we're gonna do. 100 plus 300 plus 50 gives us 450 ohms. So that's our total resistance. All right, very good. Now, you may be sitting there going, what on earth do we do next? Herein lies the beauty of the VIR chart, okay? Because we know that current equals voltage divided by resistance, right? That's Ohm's law. This is on your equation sheet. If I want to get this V by itself, I have to multiply both sides by R, right? This is division, so I do the opposite, multiplication. R divided by R is 1, and this gives me the following equation. V equals I times R. Look at that. Look at this. V equals I times R. Well, that's our chart. And here is the beauty of the chart. Voltage equals current times resistance. And we can use this to fill in every column, or excuse me, every row of our chart. As long as you have 2 numbers in a row, you know that R times I equals V. So in this case, we need 450 times what equals 9? Well, that's this equation. 9 equals I times 450, right? Okay, V equals I times R, okay? Well, this is like any other equation. This is multiplication. So in order to solve this, I have to do the opposite of multiply, and I divide both sides by 450. 450 divided by 450 is 1. And 9 divided by 450 is, how do we find that? We go to Google, and if you just type in 9 divided by 450 and hit enter, a calculator will pop up that you can use, okay, for anything. And we know that that is equal to 0.